Hello, welcome to week 2. For your beginner lesson this week, we're going to talk some more about geometric formulas. Again, a lot of these might be a review for you, but we want to make sure we covered them because you're going to be using them in problems throughout the summer. So, first one, area of a triangle. Well, the area of a triangle, one way to think about it is to draw in a rectangle. If you draw in a rectangle, you can always draw a triangle like this. Well, it turns out when you draw on this length right here, which we call the height, and we call this the base, the triangle is always half the area of the rectangle. So we call the area of the triangle, area equals 1/2 times the base times the height. Well, the only thing that's challenging about this is knowing what the base and the height are. So in our particular problem that we have shown below, there's one way to draw the base and the height. One is to let this right here be the base, that segment. The base is always the side of the triangle. And then the height always goes from one of the vertices, so one of the corners, so it's the one that's opposite the base, and you draw in a line, and the key is this line has to be at a right angle. If it's not at a right angle, then it's not the height. So in this case, that's the base and the height. So if you knew those, then you could find the area of this triangle. However, there's other ways to do it as well. So for instance, let's say we take this triangle and we rotate it. If we were to rotate it and make it look like this, we can have a different base and height, right? Remember, this time, base is the side of a triangle, and then the height is always a right angle to the opposite vertice. And so that's your base and your height. So it turns out that every triangle, there are 3 different ways to find it. The base and the height. Now, there are a couple specific examples I want to go over before we move on to circles. The one case is if you ever have a right triangle, like the one on the left. A right triangle is easy because you always let this be your base and this is your height. And it actually doesn't matter which one's which. But if you notice, from the height is at a right angle to the base and it goes to a vertice, and so that's why it can be your height. So for instance, if this was 6 and this was 8, the area would just be 1/2 times the height times the base, which turns out to be 24. And that would be a way to do that problem. But remember, in a right triangle, you just multiply what we call the legs together. In a obtuse triangle, like the one shown on the right, well, if we let this be the base, the height is a little bit weird because you can't draw a straight right angle from the base to this vertice. So what you have to do is you actually have to extend the base so that we can get it to a right angle, and so this becomes a height. The base is still this length, right? We don't care what this length right here is. The base is still the side of the triangle, but the height is a right angle to the line that would be the base if you extended it. Okay, so that's for triangles. The other thing we're going to look at are circles. Circumference of a circle is always just the perimeter of a circle or the area around. Imagine having a circle, for instance, like a can. A can is in the shape of a circle. If you just take it two-dimensionally, if you put a string around the can, that would be the perimeter or the area, the distance around the circle. The way we find the circumference, well, circumference is always one of 2 things. The first one is 2 pi times r, well, where r equals the radius, and pi is a irrational number that starts out 3.14 and it goes on forever. Pi is a constant number. It's a value. It's something we'll talk about in a second. The other way you can do circumference is you can also do diameter times pi, because the radius of a circle is always half of the diameter. Diameter goes all the way across the circle through the center. Area of a circle, well, your area of a circle is always pi, again, the same number right here, and then it's just radius squared. So to find the area or the circumference, all you need to know is the radius. So the radius is really all that matters when we're talking about a circle. And the radius, if you don't know, is from the center of the circle to the outside of the circle. And so when we're looking at these, we do want to talk about pi just a little bit. Notice I told you that circumference equals pi times the diameter. Well, the way that pi was developed is using this formula, in that if you divide both sides by diameter here, you find out that pi is just the ratio of the circumference to the diameter. It is not an exact value. If you went on forever and ever and ever and ever, it would not never end. So a lot of times 3.14 is used to estimate pi, but when we do our problems, we're going to leave our answers in terms of pi. So pi will just be a part of our answer. We know that means we're multiplying by something very close to 3.14, but we don't know exactly what it is. Okay, check out part 2 to this lesson to do some examples using these formulas.